Okay, one of the questions was, how do the videos look like? So in the rest of the afternoon, we will see first, we will talk about the videos. What kinds of videos can we produce? What are things to take into account when we produce videos? This is the first part, part one. And then after the break, probably, we'll talk about activities, about exercises, quizzes, social interaction. So let's start now with the videos. This is the summary. First, we will talk about kinds of videos, more or less a taxonomy of videos and best practices in production of videos. Second, we'll talk about phases, 3 phases, pre-production, production, post-production of videos. Then we'll talk about some things to take into account when speaking in front of the camera. And then we'll talk about another important issue, which is the copyright issue. If I use other resources, can I take everything I find around, or is there something to take into account? So let's talk about these best practices. The curtain opens. Good. First of all, I think it's important to reflect whether one particular topic is best served when shown in a video, or whether there are other possibilities to explain this particular topic. For instance, here is an example, and when we try to explain the digital representation of numbers, of natural numbers. I made a video to explain if you have 8 bits, 1 byte, how many numbers can you represent, etc. This is one way of doing it. It's a good way of doing it, but there are other ways as well. For instance, here, it's just, this is an image, but it represents an app, a JavaScript application that can be used by the students so that they can write here the number in binary, and then they get it in the decimal representation, or can write it in the decimal representation, they get it in the binary representation, so that they can play a little bit, and in this way, better internalize, better understand what is the digital representation of numbers. So a video is good. Also, you could use just a page explaining things. This is much cheaper to produce than a video. Or you could use something interactive application. So in the end, we use the 3 possibilities for explaining this particular thing. Maybe first an introduction, then a review, and then, okay, play with it in order to really understand when you have the maximum number you can represent, etc., to really understand it. So combine the different ways of expression in its full potential to really express as you want to do. The different modes cost more or less. So this is the cheapest one, just a text. It's very powerful. The student can scroll up and down very easily, so it don't undervalue this possibility. A video is more expensive. You need to go to the studio. If you have an error, maybe you have to do it again, record it again, etc. An application, of course, you need a programmer to write your JavaScript application, but then it's very useful, and maybe you can use it at different moments. So really understand the different possibilities you have and try to choose the one or the ones which are best suited for the particular purpose. Some errors, Carlos already said before. I mean, you don't need to do a Hollywood video. The important thing is that from the educational point of view, it's a good video that tries to convey the right message. Maybe the audiovisual part is not so important. It's more important to have the educational part. Fine. Then let's go to some recommendations. Yes?
You didn't touch on recording the entire class.
Yeah,
because
yeah.
That's what's
I mean, we talked about
happening.
it also yesterday. What is the length of the video? And I skipped about because we have Well, maybe I'll go here.
Yeah, because that's what's happening typically.
Yeah, I mean,
people want to record the entire class and upload everything.
Yeah,
you know, to
I mean, before the MOOC platforms came out, we have seen many videos which were 45 minutes long, etc. No? And as I showed yesterday, this analysis done by edX, after 6 minutes, the attention goes down. So it's good practice not to do very long videos. 6 minutes long videos is a good measure, but it can be even shorter. So yes, in fact, don't record the entire class and then a posteriori try to divide it. It's important to divide the content into small pills and record them separately. An analysis done by several researchers that the amount of video seen by students is longer if it's put into small pills. So in the end, the length of the video seen is longer if the videos are not so long. This is proven. This is there are several papers about it. It's not a matter of opinion of myself, but it has been shown scientifically that the students, the learners, see more videos if it's in short pills. Even if, as you said, you can stop it. Because sometimes if you see a long thing, maybe you don't have the courage to do it. But if it's a short, okay, I'll see another 3-minute video, I have time. So maybe in small pills, then at the end you get further away. Yes.
Yeah, so maybe a comment related to that is that it's good to have videos and activities or activities that are that follow the videos, no? So that you can reflect about what was told in the video. If you have a very long video, maybe you reach the end and you don't remember anything of what was said at the beginning. So it's good to have something shorter, then you have an activity that helps you reflect on that, then you go to the next video. So this is a strategy that has been followed and it's been followed by most MOOCs and that is supported by scientific papers. Of course, it depends on the kind of video. If you have very good communication skills, maybe your learners will keep the attention for more time. But in general, and this study is for an average, I don't know how many thousands of videos they analyzed, so this is the average number they got, no?
Okay, so recommendation, video pills, 3 to 7 minutes. Learners watch more time with short videos. And then some special equipment is needed. We'll talk about it also later on. About the video, this is a very interesting analysis done by EPFL, École Polytechnique Fédérale de Lausanne. They analyzed where learners look at with this gaze recording. So these points here are, if it's red, it's where the learner look at one particular second, the position on the screen they look at. No? And they realized if there's some pointer, here you see a hand with a stick pointing to some particular place, that the learners were looking for this place. Here it was scattered here, there, and there, and there at this particular second. So if you want to point the attention to one particular place, it's good that you have some pointer. No? So using some animations, some pointers, helps to focus on particular things and therefore help the students understand better. Of course, this is more costly because you need to have the equipment, you have to have the recording, the capturing of this hand as well as of the background, but it has been proven here also that it helps in keeping attention. So now to your question before. What kind of videos do we have? This is a taxonomy that we have defined, trying to categorize different kinds of videos according to several characteristics. I have 3 columns here. One is videos where there's a person, the teacher, visible on screen. On the other side here, more like Khan Academy, where the teacher is not present. And in between, you have some other presentations where a hand, basically, a hand with a pointer is present on screen. So let's go through these different modes. Probably there are many more, but I think we've covered a lot, and to see what equipments do we need for this particular purpose. This is more the kind of old style videos where the teacher is there, and this is at least more modern or MOOC time videos. So let's start on the left. A person with a blackboard. This is just a classical, traditional recording where the professor is using the blackboard, and you can see the class with the professor with the blackboard. For this, you just need a camera, and that's it. This is Agarwal when he was younger. Here, he was even younger than that. And he, apart from the blackboard, he used some experiment, but physical experiment that he was doing on class. Then you can improve that a little bit, and rather than having one person explaining, maybe you can have a dialogue. Maybe you can have one person asking a question, the other one replying, so that maybe you as a student, you identify yourself with the person posing the questions. You are a bit more involved in the whole scene. For this, just you need also a camera. Now we're making it a bit more complicated. So you see a particular person and maybe some images, not the blackboard, but some images which are some put in the screen. So in order to illustrate some points or to illustrate anything. This is also more old style, where you have a PowerPoint and the person maybe in one corner illustrating it, but the most important thing is the PowerPoint. And the different ways of inserting the person into the PowerPoint. This is even more old style, where you could see the person in one particular corner. Now, very similar, but quite different, on the other hand, is now you have here the person, and here you have a PowerPoint or a Prezi, but where you can annotate. So this goes more into the direction in order to point the attention to one particular place, so that the person looks at this particular place. There's a lot of places the person can look, the student can look, but if you annotate, then you direct the attention to this point. So you have the person there speaking, you have the content, and you have these annotations. This is a very interesting one, which is by, I think, Udemy, if I don't remember incorrectly, where you could see the person speaking. You could see the content, which is being annotated, in this case with a mouse pointer and maybe with some colors. But the interesting thing is he was teaching HTML and JavaScript, is that this video was switchable with just one click into a web page, so that you clicked somewhere, this was converted to a web page, and you could make changes and see the result of these changes. In this case, HTML, you could put some HTML code here and there, and you see there, and then you could continue with the video. Of course, the changes you have made disappeared, but you can hear some explanation of some HTML, and then immediately you press a button, check some changes, and then continue the video. So it's not just the video, it's the video with you being able to directly interact with this content, which I think was quite interesting, quite clever. Of course, you cannot do it for everything, but for these HTML-like languages, it was very useful. Let me show you now. Let's move to the video with a hand, not with a person, but with a hand. So this is writing on a desk. You have a central camera pointing to the table, and there you draw something, you show something, and you record your voice at the same time. You can write something, or you can also make experiments, electrical experiments, and you can very nicely show what is going on. Maybe a light turns on, etc. You can also use just a PowerPoint on paper and point to it, as well as recording your voice. This is quite simple. Let's make it a bit more complicated. This is done by several, by Coursera, by many other MOOC platforms, where you have something written, and you record what is written, you record the voice, and you record also the hand. But look at this. The hand is semi-transparent. So you have really two sources. The source of the thing you write from the back, you could say, and the central camera recording the hand, but it's made transparent in order to see what is below, so that the hand is pointing to places in order to focus your attention, but it's not hiding anything. You can see everything at the same time. So I think this is very useful. We have used it also in some of our MOOCs, and it's very informal, very clear. It's a very good way of thinking. For this, you need, the camera for record the hand. You need a tablet from which you capture whatever you're writing, and you need, of course, some tools like Camtasia in order to capture these contents and combine. Now let's move over to some modes where there's no hand and no person, so more Kant style. For instance, this is just some sequences of images. Okay? This is the handwriting by Salman Khan, for instance, where he uses different colors and he writes on it, and at the same time as he records the voice. Of course, you can combine this with additional images, for instance. You write something and you add images on top. Or you can just write over PowerPoint with animations and no hand in this case, but audio writing. Another possibility, especially for teaching programming, is to do a screencast. You record what you see on the screen at the same time as your voice, and you can write some programs and see the results, compile, execute, whatever. We have used it also quite often. Carlos has done many of these. So just capturing your screen is a very useful way as well. In this one, we have the writing, we have the images, and we can also add some apps to do some calculations, etc. So, this is a collection of possibilities. Probably there are many more, but basically you see the person, the hand, and I think this is one of the more interesting ones, because it focuses the attention on particular points. You don't need to see the person. After some time, you get bored of the person. Sometimes it's good to see at the very beginning the person, the teacher, but after some time, you just don't need it, just need the voice, so this is enough. And, then the writing itself, and maybe doing some animations, which are also useful. Okay, so this is your question hereby answered. No? So there are a great variety of possibilities. You need different tools. You need different settings. For instance, at our university, we have basically two kinds of spaces. One is a space to do something like this. So we have a green screen. The person is being captured, and then this green is replaced by some PowerPoint with images, etc. So we have this studio. And then we have other smaller studios where we do the capture by hand. So that we have some tablets, the writing. This is more you don't need personnel there. So the teacher goes there, captures something, and that's it. Now, for the content, what the thing you see on screen, there are also many studies which has been interesting on how to combine images and text and speech. I would like to refer actually to a relatively old, 2009, already old, analysis by Richard Meyer about multimedia learning, because in a video, basically you have two sources of input. You hear something and you see something. You have two channels in which you combine. No? You have maybe words and pictures. So you see something through your eyes and you hear something, ears and eyes. So these are two channels. And if you're not done correctly, rather than helping, it can be confusing. So, and this Maya analyzed these two channels and how can they combine in order to help understanding and help short-term and long-term memory. And he has some recommendations. These are these recommendations. Now, am I doing it right? No, this is not the right way of presenting it. No, a lot of text and speaking at the same time. I'm not using the two channels correctly. So let's go through it, through these 10 recommendations one by one, and with images also trying to explain what is the good way of doing it. For instance, he says, deeper learning is obtained from word and picture, both things, rather than word alone. So if I show a picture and say something or write it, or basically say it, then the understanding is better and the memory is better than if I just write it. So this image would be better than just putting something like this, a lot of text. No? So image accompanying the word helps better to understand. So think about it. When you're designing or your PowerPoint for the video or preparing the video in whatever way, try to accompany the word with some image that illustrates this. I will go, more or less fast through these recommendations. This is the one. Redundancy. Deeper learning when words are presented as narration rather than both narration and on-screen text. So it's better. This is a bit opposite to the other one. So if I say something and have text, it's worse than if I say something. This is what he recommends. Yeah. Of course, some of this might depend very much on the context and on the particular thing, but this is his recommendations. So deeper learning, when words are presented as narration, the speaking is better than just the text. Temporal contiguity. Deeper learning, when corresponding text and pictures or animation are presented simultaneously rather than successively. So it's better to have good and symbol than afterwards, successively. Better if you see it at the same time. And there are many other things. It's just some to give you an idea of the many recommendations that exist. Interactivity. If the learners have the possibility to interact with the content themselves, then also the learning is better. This is why interactive things are much better. For instance, when we talked about the digital representation, the binary representation of numbers, it's better if the students play with it rather than explaining it. So interaction helps understanding. Deeper learning when learners are allowed to control the presentation rather than when they're not. Deeper learning, people learn better when the words are conversational style rather than formal style. So more direct, more conversational tone, informal tone is much better than it's very formal. Okay? Deeper learning when words are presented as narration rather than on-screen text. So it's better to hear something, so it's through the ear, rather than just through the eye, the text, the narration, the explanation, the verbal explanation. Better if explained. Spatial contiguity. Deeper learning when corresponding text and pictures are presented near rather than far from each other. So this is an example. If it's near, better than if the same is separated. Coherence. Yeah. Extraneous narration, sounds, images, and video are excluded rather than included. So try to focus and not have extraneous additional signs or symbols or images that just only make it more difficult to understand. And so there are a few more, but people learn better when the words include cues about the organization of the presentation or individual preferences, stronger for low knowledge learners and stronger for high special learners. Okay. So, I mean, we don't need to agree with all these recommendations. They are from 2009. It's prior actually to MOOCs, but there's some reflection about these two different channels and how to combine them in the best possible way. So there are lots of theories, a lot of possibilities there, which we should take into account. Now let's move over to some other, I think, recommendations that are useful for planning your videos. You should think of whether to concentrate more on the theory or also have videos about practice. And it depends very much, of course, on the topic you are teaching, but try always to have some practical videos as well. For instance, this is for physics with a cenital camera to make some experiments. This is always very useful, not just the pure theoretical physics. This is about structural mechanics, where a bridge is built with apples, and to see how you can best make it. This is theory, but it is some exercises in physics, mechanics, and this is some programming exercises. So try to balance, try to use not just one kind of video, but several kinds of videos that make it a bit more destructive. Of course, rather than using just monologues, we've seen it before, try to use this modality of conversations, dialogues, that can be also helpful. Also, not just the teacher, try to have invited experts about topics in order to have another opinion. This is David Cormier, the man we saw yesterday, the person who invented, who coined the word MOOC. This is Pierre Dillenbourg, etc. So always try to have additional views, maybe with a different perspective that enrich the whole explanation. And then there are many settings you can use. You can record in your classroom, or you can record in the studio where you have superimposed images. You can record at home. You can go on site. This is Professor Antonio de las Heras of our university. He went here to Bletchley Park, where Alan Matheson Turing did the experiments. So going places, of course, is much more expensive because the recording personnel, etc., has to go there. But it can be quite, make good suggestions on the topic you're explaining. It might seem more real. Sometimes you don't even need to have the personnel going to record. You have a camera and you record yourself. Okay, so as I said, it's not so important to have the high production videos rather than interesting videos with a lot of suggestions relating to the topic. So now for the video content. Try to be original, try to be imaginative, try to be shocking, try to be funny. This here I was explaining overloading in Java, so I overloaded myself. And there I was explaining recursion, and I used this dolls, these Russian dolls, etc. So make an extra effort on trying to take the concept when you explain to the limits. What are the consequences of it? Try to explain complex concepts in a simple way, but using real-world objects. Let me show you some examples of this. This is Walter Lewin. This is a famous MIT professor, famous for these physics lectures. He was explaining here the pendulum and the conservation of energy. Let me show you the video.
Conservation of mechanical energy, that I am willing to put my life on the line. If I release that bob from a certain height, then that bob can never come back to a point where the height is any larger. If I release it from this height and it swings, then when it reaches here, it could not be higher. There is a conversion from gravitational potential energy to kinetic energy back to gravitational potential energy, and it will come to a stop here. And when it swings back, it should not be able to reach any higher, provided that I do not give this object an initial speed when I stand here. I trust the conservation of mechanical energy for 100%. I may not trust myself. I'm going to release this object, and I hope I will be able to do it at 0 speed, so that when it comes back, it may touch my chin, but it may not crush my chin. I want you to be extremely quiet, because this is no joke. If I don't succeed in giving it 0 speed, then this will be my last lecture. I will close my eyes. I don't want to see this. So please be very quiet. I almost didn't sleep all night. 3, 2, 1, 0.
Okay, so this is a simple example, the conservation of energy, but he explains it in a very live way, in a very dramatic way, you know? And I think this is very important, to think how whatever you want to explain here, the conservation of energy, is very well remembered. And I think the students there, maybe also you, will remember this very well. No? It's the video. Is, okay. Let me show you another example. This is by Anant Agarwal in this first MOOC he did on electronic systems and circuits, or circuits and systems. And he wants to explain noise in systems, and then he takes this one here. Is this the one?
A processed output. So the 1, 0, 1, 0, 1, 0, 1, and the output is simply going to be, this is my time axis going this way, is going to be a ANDing of these two signal values like so. What I'm also going to show you is I'm going to superimpose noise on this wire. I'm going to superimpose noise on the wire, and what I want you to observe is the output of this digital gate. Is the output will stay exactly like this, even though I impose noise. The ultimate test. So stay right there. Let's do this demo. Give me a couple seconds. Try it. So if you look at the signal up there, look at the middle waveform, and I'm imposing, let's have a digital system in a noisy environment, like a lumber yard, for example, or, chopping a bunch of trees in my backyard, building digital systems on the side. And, if I have my buddies, revving up chainsaws, I'm superimposing noise on my second input, but look at the output. And just to know that, show that I'm not bluffing here, what I'll do is I'll pass the noise through and make the noise larger.
Very simple thing, AND gates, noise, etc. But he makes it very live, and I think this is a good example of making something memorable, something which the students will never forget. This is another example from a professor at our university, Carlos Santiuste, of structural mechanics. He builds a bridge with spaghetti. It was actually an assignment done for students, and he explains then possible solutions. So everything, something simple, but which is very close to what we can remember, etc. So we are behind schedule. Now, shall we stop here, or shall we continue a bit more? Because actually, the coffee break should have been.
It's up to you. If it's, I mean, the time is flexible for the coffee break. Actually, more the overall time we would like to finish by 5. If possible.
Okay, so we can make a stop here, and then we'll continue talking about more videos, and then afterwards we'll go with activities. Okay. Well, thank you very much. So.